Okay everyone, I come back with you with the second video of physical changes. You will see the things that I will explain it now. These are just some examples that I really want to talk about them. The physical change, guys, is different from the physical property. The physical change, what do we mean by physical change? Let's to read and then I will say to you. When a substance goes through a physical change, some of its property may change, but it doesn't become different substances. Okay, if I give you an example, guys, I've got this paper. I can cut down this paper into some pieces of the papers. Do you think that the physical change? Do you think that something happened to this paper? Yes, only the physical. Let's say that only physically it changes, right? So I cut it, or let's say that I cut it into some pieces of paper, so it became only the physical changes happened. As you can see that it's changed the shape and the size, it became smaller, but it will not produce a new substance. It will not, right? It will not. Does it become a new substance? No. Like only if I burn this paper and it will become coal inside of my hand, like only if I burn this one it will become coal. I can say that this is a chemical property or chemical change. But when I will just cut this paper into smaller pieces, only physical changes happen. Only physical change. Some of them became big, but the other one becomes small, and also the shape changed, right? So I can say this one is a physical change. Another example of a physical change is let's say that it is water. When I freeze this water, so guys, this water and this one, both of them, they have the same particles, but so we say that only the physical changes happen from the water. This is liquid and then becomes solid, so nothing, the particles of water never change. It is the same particle that we have it, which is H2O, but only the physical changes happen. Like from liquid it became solid, so the shape, it changed the shape, right? What about the molecules? Like, do you think that something happened to the molecules? I will show you from this picture that I drew it for you. If you see this one, the first one is solid. So if you see the solid parts, so the particles of the solid, they arrange it in a regular pattern. So they are arranged in a very nice way, as we can see that, and we can say that this is a solid part. What about liquid? The particles of the liquid close together, but they are not regular. As you can see that they are so close together. So in this liquid, as you can see that, we can say that the particles of this water or the liquid, they are just like this. They are close together, but they are not arranged. So this one, in the solid, yes, they are arranged, but in the liquid they are not arranged. What about the gas? In the gas, the particles, they separated, and also they are not regular. As you can see, like some of them, they are moving from this side by the other side and move down, and then some of them, they are just staying at the center of the let's say that container, right? So these are, we can say that only the physical changes happen to the water, from the solid and then to the liquid and then to the gas. Nothing will happen. If I said to you this one, all of them, they are H2O. Like from here it's H2O, and from here it's also H2O. What about gas? Still this one is H2O. So we say that it will not produce a new substance. It is only change the shape of from solid to become liquid and then to become gas, rise up in the atmosphere, right? From the liquid, from the solid to become gas. Only the shape change, and also the molecules of the water, they will stay the same together, but here they are just separate. Let's say that they are close together but not regular, but from here they separated from each other and they are not regular. Okay, now we know that in the physical change, always remember that we will not produce new substance. New substance will not be occur. Only physical changes happen. As we say that if I cut this paper into 1,000 pieces, only the shape and also the size, it will change to become bigger, smaller, or let's say that any of the shapes This is a physical property of matter. We have more examples that I will read for you, and you will see that. Okay. A piece of paper cut into hundreds of tiny bits goes through a physical change. Yes, we say that when I am cutting down this paper, it will become 1,000 pieces, and it will only change the shape or the size. So does the ground when a hole is dug. It's just like this, guys. When you have, let's say that when you are digging a place which is look like a garden, right, you are just removing the soil from that place. So the soil, it will be here. This is the soil, right? Let's say that this one is your garden. When you are removing the soil from here to here, the soil, it will stay here. So we say that this soil, which is from here, which it was here, when we are removing to become here, it is the same soil. So we say that this is only physical change. It's nothing will happen. It is the same soil, but we remove it from one place to another place. So we say this is another physical property of matter. Removing soil from one place to another place, also this is a physical property. Or sometimes when you see a mountain, and the mountain, when you see a mountain, some of the tiny drops of the rock or the soil, it will be removed by the rain sometimes from place to another place. So it is the same soil, or it is the same rock that can be moved from one place to another place. As this one also we can say this is a physical property. Only they are moving from one place to another place by any natural factor which happens. Let's say that if it will be by water, if it will be by wind, or if it will be by any factor. Yeah, they are physical properties, because they are not producing new substances. If the new substance will be formed, we say this is chemical change. But if the new matter will not be formed, we say it's only physical property. Let's say, as we say that only changing the shape, changing the size, they are physical properties. Okay, let's continue. The paper may be in the bits, but none of it disappear or being changed into another material. The dirt that has been dug out of the hole may look different, but it has just been broken up and moved around. This is the same example that I gave it to you. I'm going to remove the soil from one place to another place. This is the same soil, but I can say that I just remove it from one place to another place. Okay. In a physical change, the molecule and atomic makeup of a substance stay the same. This is the same thing that I said to you. This is H2O in the solid form. This is liquid in the this is H2O, same H2O in the liquid, and this is the same H2O in the gas. So as I said, the molecules will not change. All of them, they are solid. All of them, they are H2O. So when you see that all of them, they are like the same, we say that this is only physical change. We don't say this is a chemical, because it doesn't produce new substances, because the H2O never changes. It's H2O from solid, from liquid, from gas. Yes. So when I finish, I'm gonna highlight for you. This is, I just wanted to read for you, and will give you the examples. Yeah. Okay, as we say that in the physical changes, the molecule and atomic makeup of a substance stay the same. A sandstone cliff that's exposed to the weather goes through a physical change, and it gradually erodes in the wind and rain. As I give you an example of this one, I said when it's, let's say that small rocks or small particles of the soil, it will be by rain, or if it will move by the wind from one place to another place. This is the same physical property. Okay, guys, it gives a lot of the examples, but I will read for you. It's okay. So quartz, the main part of most sandstone, is a compound made up of silicon and oxygen. So this is it gives another example, which is quartz is made up of two things, which is let's say that, which is silicon, and also the other one is the oxygen. Okay. Let's see that
metal that allows it to be.
Wait, I wanted to show you the one of the examples of what is it? Quartz. Okay, here is it. I found one of the pictures of the quartz. This is quartz. It just look like let's say that it is look like Diamond, actually, it's something so nice. Okay, what is made up of? The quartz is made up of what? It is made up of silicon and oxygen. Okay, atoms arranged in a specific way, right? Okay, as the cleave erodes, its spaces are still made up of the same silicon and oxygen atom. So guys, I have this quartz, okay? When I have this quartz, I'm gonna break down this quartz into 1,000 pieces. They are made up of what? They are made up of two things. What are the things? So we say that quartz is made up of what? Oxygen and let's say that silicon is made up of oxygen and silicon. If I have this quartz, okay, if I have this quartz, I will break down this quartz into smaller pieces. If I see this one is made up of oxygen, oxygen and silicon, what about this? Stay the same, oxygen and silicon. So only the physical changes happen, no chemical changes happen, because I just break down this oxygen, this quartz into smaller pieces, which is the molecules of the oxygen and silicon stay the same. This one is made up of oxygen and silicon, this one the same, oxygen and silicon. Yeah, so new substances will not be formed. Still we can say this is another physical property. Okay. The physical property of a substance determine which physical changes it can be undergo. For example, aluminum can be rolled into a thin, flexible foil that will not be break when it is bent and shaped. Rolling, bending, and shaping are physical properties are possible because of physical property aluminum. It is malleability. Okay, let me show you another picture of aluminum. This is another picture of aluminum that we can roll the aluminum, and also another one is we can bend aluminum. So when we are changing the shapes of the aluminum, when we are changing the shapes of the metals, we can say that they have two properties. What are the two properties? As we talk about always, one of them is malleability and the other one is ductility, right? So when we are changing the shape, now we can say that the aluminum, when I am changing the aluminum, from bending and then rolling, I just changed the physical change of aluminum. I didn't do anything with the aluminum, right? I just changed the physical property of the aluminum. As I said, when I have like this, let's say that this is a wire, or when I have like this is this one is malleability and this one is ductility. Okay, when I have like this, I change it only the shape to become like this, right? So I didn't change anything from the aluminum. Still the particles of the aluminum, they are the same. Still we can say this one is aluminum and this one is aluminum, so nothing will happen. Still we have the same aluminum, right? So we said still this one is the physical property. Okay. People make good use of the properties of substance. Copper is used for electric wiring, for example, because it's ductile and conductor electricity well. Okay, gold is used for jewelry, not only because it's rare and it's good, but also because it's high malleability and ductility. Why I put my ring here, guys? Only to show you that I can change this gold to become in different shapes and different, let's say, different shapes. And why? Because it has two properties. What are the properties? Is malleability and ductility. Because I can change it in a different shapes of let's say that different shapes, so I say that this one is a physical property. If I change it to become malleable or ductile, if I change this one to become a malleability or ductility, still I will say this one is gold. So remember that when I will not change the physical, when I will not change to become a new substance, this is, I can call it as a physical change. In a physical change, always remember that the new substances will not be formed. It is only the old substance that we have it. If you look at this balloon, when you have the balloon in a small way, but when you are blowing them, they are the same balloon, right? Let's say that this one is the small balloon. right? Okay, this one is the small balloon, but after when you are blowing them, they are the same, right? When a balloon is filled with helium, the shape of the rubber changes, but its mass does not change, so they are the same balloon. Yeah. Okay, I will stop from this video, but for the next video, I will just make the highlighter for you, and I will see you.